Highgrove Online School is a school like no other. Traditional British education online. Our world-class team teach through a powerful combination of self-study, live lessons, and individual support. Our learning coaches provide weekly one-to-one coaching and encourage our students to develop independent learning skills. Highgrove is a gateway to the most selective universities in the UK and abroad. A modern, tailored experience for ambitious young students who can study full-time or part-time to fit around other commitments. Wherever you are in the world, whatever your dreams, we can help them become a reality. Highgrove Online School, an outstanding British school online.
Hello everyone, welcome to this evening's Highgrove Online School taster lesson for Maths GCSE. It is lovely to have you all here, and I do thank you for joining us, whether it's evening, morning or possibly afternoon, depending on where you're based. For those of you that don't know me, my name's Rosie and I work in the school's admissions office. In terms of the plan for today's session, I'll provide a brief overview of Highgrove Online School before I hand over to Mr. Harry Williams, one of our expert teachers, who'll be leading the taster lesson today. And then we'll finish with a chance for any questions. Before this though, there's a few bits of housekeeping to go through for today's session. We do welcome questions throughout the event, and we'll answer these in the Q&A session at the end if we haven't managed to answer them as we go along. If you type your question into the chat box that you can see on the screen there, that will be public, so anyone attending today's session will be able to see your questions or your comments. If you type them into the Q&A box, that's private, so it will only be visible to the staff of Highgrove Online School. But either way, please do ask questions. It's always great to hear from you, and as I said, hopefully we'll be able to answer any as we go through, or certainly in the Q&A session at the end. So starting off with some general information about Highgrove. Highgrove is an online school that's designed for students who want to perform to the very best of their ability at GCSE and A level. We're a high expectations school. It means we have high expectations of our pupils and of our teachers, but we're also a highly supportive school where we go the extra mile to support those around us. We aim to give students the very best possible education, which means, of course, achieving the best examination results, ones that they can feel really proud of. But it also means giving pupils opportunities to develop their knowledge and their skills beyond exams, to give them opportunities to develop teamwork and leadership skills, to engage in clubs and societies, to develop friendships in a global school community, basically to offer the very best of an all-round British education, but online. We speak quite a lot about individual options for pupils, but I know that some people joining us today might be from schools and colleges, possibly looking for how we can support them and their pupils. Highgrove Education partners with educational organisations around the world to help provide their pupils with flexible education of the highest quality. From cover supply teaching to one-to-one tutoring and through to the provision of an entire sixth form curriculum, we can provide a flexible range of outstanding teaching and learning services how and when you need them. It means there's options for your pupils to have their own dedicated teacher and live lessons, or to join one of Highgrove Online School's classes, or for you to use our interactive self-study materials with your teaching staff. So options not only for individual pupils, but also for those of you that might be joining from schools and colleges looking for some support. So either way, whether you're an individual or you're coming from another organisation, the approach to course design we take at Highgrove remains the same, and it's based on the use of a flipped classroom teaching methodology. This involves students working through the interactive self-study materials to develop an understanding of subject content, and then having a lesson in a virtual classroom where teachers explore their understanding of that material and get them to apply and extend their knowledge. We're going to show a short video now that will give you a feel for what the self-study platform is like. The example given is actually part of our Maths A-level course, but you'll see similar features across all of our core subjects for GCSE and for A-level.
Let's take a look at an overview of the IAL Maths self-study course. You can see we've got an extensive library of interactive self-study materials. Much of the self-study materials are interactive. You've got everything that you need all in one place. No need to go searching on YouTube or looking things up in other textbooks. Your teacher and your mentor are able to see how you're progressing to ensure that you get the support that you'll need. All of the content has been written by subject experts who have a proven track record of supporting students to exam success. You can see you get really detailed feedback instantly on completion of each section. That helps you keep on track. Our maths course has extensive video solutions, so you can digest the maths at your own pace. Make sure that our calculator is in degrees mode. Remember, shift, setup, angle units, degrees. Make sure it's showing a capital D on the screen. Then we enter this into our calculator. Handwritten solutions and answers allow you to quickly check your work, so you don't necessarily need to watch every video if you're progressing well. Our self-study platform gives you the flexibility to study when and where suits you best. We have extensive exam practice built into the course, so that by the time you get to the exam, you're feeling confident and ready. We have detailed model solutions so that when you make mistakes, you can learn from them. Our courses help you to develop your subject knowledge while also developing your ability to learn independently. We hope you like them as much as we do.
So hopefully that video has given you a bit of a sense of what our self-study material feels like. This slide hopefully will give you a sense of what a typical week might look like for one of our full-time pupils. This is actually an A-level timetable, but what you can see is the combination of fixed live lessons, house meetings, elective courses, and extracurricular activities, which will be similar across GCSE and A-level. Of course, what you don't see here are the self-study lessons, as they can be completed at a time and a pace that suits the pupil. So that's what a typical week might look like. Now it's time to see what a typical lesson might look like. Before I hand over to Mr. Williams, I should say that in lessons at the school, all of our pupils and staff have their cameras and microphones on, and teachers would make use of breakout rooms and a wide range of other interactive activities. For reasons of safeguarding, however, we can't do this for taster lessons, but what we can do is allow you to see our teachers in action and give you a sense of the impressive functionality of Adobe Connect, one of our state-of-the-art learning platforms. So with that, I will hand over to our Head of Maths, Mr. Williams.
Thank you so much, Rosie. And thank you everyone for joining me this evening, or whatever time it is where you are. Definitely excited to share some maths with you today. Let me just move to a different view. I've got some puzzles prepared for you. Let me just share my screen. So it's going to be slightly different to how I normally run a maths lesson, in that we're going to be using Adobe Connect much more in this lesson, the platform you're on at the moment. In my normal maths lessons, I would normally invite all of my students on to join a Miro board. This is an interactive whiteboard. I'm just sharing my screen here so you can see this is what Miro looks like. And normally we'd have all of the students on the board, and they all tend to use graphics tablets or iPads, a variety of things. Some of them are on their laptops, some are using iPads, and then they join on the board, and then everyone can write on the board at the same time. You know, you can choose your pen color. It's a great system. So today I'm going to be writing on the Miro board, so you get an idea of what it can do, what it looks like, and I'm going to ask you to engage in some polls on Adobe Connect here. And at the end, if we have some time, I might invite you onto the Miro board too, so you can check it out for yourself. But we'll do that later if we have time. So the first thing I'd like you to do, a little challenge for you, we're going to be talking about probability today. I'd like to hear your opinion on why you think this statement is not correct. So the claim is, if you throw a fair coin and you get heads 5 times in a row, you're more likely to get tails the next time that you throw that coin. Well, why is that correct? Could you answer in the poll here? You should be able to type your answer here. At the moment, don't worry, only I'll be able to see what you're writing there. And you do need to press enter or the little submit button once you have typed in your answer there. You can see some responses coming in. Thank you for saying hello, Layla. Layla's discovered the chat as well. So a reminder, you can also put things in the chat as well. Everyone can see what's in the chat. If you just want to, privately share an answer, or you have any question that you don't want everyone else to see, then you can use the Q&A, which is just beneath the chat in the bottom left here. So I've got some great responses coming in. So lots of people are saying, because it's a 50-50 chance. And that is absolutely right. Supposing that it is a fair coin. So you could have a coin that is weighted on one side, one of those magician's coins, but then that wouldn't be a fair coin. If it is a fair coin, then every time that you throw the coin, it can either come up heads or it can come up tails. And both of those things are equally likely to one another. So those of you that said, yes, it's always a 50-50 chance are absolutely right. Now, how do we decide if a coin is fair or not? Well, that's an interesting question, even if I say so myself. Well, you'd have to do an experiment, right? So if you threw this coin maybe 500 times in a row, and maybe you got heads 499 times out of 500, then probably you'd have much stronger evidence to suggest that the coin might not be fair, that maybe somebody had weighted it in some way. So well done to those of you that got that one. Let's have a look at another one. So for the football fans amongst you, so when 2 teams play a game of football, there are 3 outcomes, right? One team can win, your team can lose, or the 2 teams can draw. So 3 outcomes, only one of those is winning, right? So surely the probability of winning must be 1 out of 3, a third. Can I ask you, if I just clear this poll for you, so you can use the same poll, can you explain to me why that is wrong? Why isn't it always the case that in every football match that the probability of winning is 1/3? Why isn't that the case? Let's give you a chance to think about it. Put your answer in the poll there. I've got some very entertaining responses coming through. So yeah, not if it's Man U versus Ruislip Rangers. Now I've got no idea about Ruislip Rangers, but I do know that Man U are in the Premier League and they tend to win a lot of matches. So I strongly suspect that in a game between Man U and any other team that's not in the Premier League, probably Manchester United are much more likely to win than to lose or to draw. So despite there being, 3 outcomes here, not all of them here are equally likely. Whereas, if you're throwing a fair 6-sided dice, there are 6 outcomes and all 6 of them are equally likely. So when you throw a 6-sided dice, a fair one, then the probability of getting any number, say like a 4, on a single throw would be 1 out of 6, because they're all equally likely. But here, depending on the teams, they're not all equally likely, right? You can have a really rubbish football team, and it wouldn't be always the case that the probability of winning might be a third. Okay, here's another one for you to have a think about. Just clear this poll for you again. So you are less likely to win with the lottery numbers 1, 2, 3, 4, 5, and 6 than if you pick numbers at random. You're probably all far too young to play the lottery, but the way it works is you pick 6 numbers out of the whole numbers from 1 to 49, and then if all 6 of your numbers come up out of the machine, you win the jackpot. You win the jackpot. So, do you think it's less likely that if you chose the numbers 1, 2, 3, 4, 5, and 6, do you think you're less likely to win than if you say picked, I don't know, like 7, 20, I'm just picking at random, 23, 24, 48, 31. Do you think, why isn't it the case that you're less likely to win with this set than this set? Has anyone got an idea about that? Because mathematically speaking, you are absolutely just as likely to win with this set as this set. But it feels weird, doesn't it? So I've got a really interesting response coming through on the poll here. Thank you so much for sharing that, Layla. So Layla's saying it's the same chance with any numbers, but you win more if fewer people share your numbers. So maybe 1, 2, 3, 4, 5, and 6 isn't the best strategy. I totally agree with you, Layla. You're one step ahead of me already, which is fantastic. So yeah, though absolutely they are just as likely, it might be that, some people just have an affinity for 1, 2, 3, 4, 5, and 6. They just like those numbers. And there might be more people that pick those, that set of numbers, 1, 2, 3, 4, 5, and 6, than this set. So though they're, each set of 6 is equally likely to come up, if this set, 1, 2, 3, 4, 5, and 6 does come up, then you're more likely to be sharing your winnings, sharing the jackpot with other people. So in practice, Layla, you're absolutely right. It's probably better to go with a random set that you think that other people aren't going to go for. But, just because it's 1, 2, 3, 4, 5, and 6 doesn't mean that it's any less likely to win than any other set of 6 numbers on the lottery, which just feels weird. Like probability can feel weird sometimes. Okay, I think I've got another one for you. So here, if you throw a coin 50 times and you get heads 40 times, the coin must be biased. There's a key word here that is the word must. Let me just clear this poll for you so you can share a view on this one. What do we think? So if you throw a coin 50 times and you get heads 40 times, must it be the case that the coin is biased? Can we explain why that isn't the case, that it must be biased? Bella, you are absolutely on the money there. So Bella said, no, it shouldn't say must. And Bella, you're absolutely right. I mean, we suspect that it probably is biased, right? Because that's quite strong evidence. It does seem very unlikely for it to come up 40 heads out of 50. You would expect, if it's, a fair coin, then you would expect on average to get 25. But you wouldn't always expect to get 25. Sometimes you might get 26 or 24. You'd have a bit of variation, but 40 seems so far away from 25 that it does feel like it might be biased, but it's that word must that's the problem. We just don't have it. We would need to do some more maths on that to check whether or not we've got strong enough evidence. It might be that the coin is actually fair. But it just happens to come up heads that many times. So well done to you, Bella. Okay, here's my final question. This one is my favorite. This always gets someone. So tomorrow in England, it will either rain or it won't rain. Right? There's only 2 outcomes, right? So therefore, it must be 50-50 as to whether it rains tomorrow or not. The probability of rain tomorrow is 50%. There must be something wrong with that. Right? Can anyone put into words What is wrong with that statement? Why isn't it always 50-50? Why isn't the probability at half or 50%? Bella, you're on fire today. Yeah, because it might be sunny. Absolutely. So, you know, it depends on where you live, right? So if you live in a really hot country, if you live in Egypt in the middle of the summer, you know, it's probably not going to be raining very often. Whereas if, like me, you live in the south of the UK and it's winter time, then probably most days it will be raining. Certainly, it feels like it's been raining where I live for many days and weeks. So you know, it depends on where you live. Just because there's two outcomes doesn't mean that they're equally likely, right? It depends on where you live. If you live in the UK, probably, and it's in the winter time, it's probably more likely that it's going to rain than it won't rain. Okay, so just be careful with this. We've got to think really hard about probability, which is one of the reasons why I love learning about it. Okay, so let me move us on to this view here. So we're thinking about how can we talk about probability in terms of numbers. So probability is a numerical measure of how likely or unlikely an event is to occur. So normally we write these as fractions, but you can write them as decimals. So like with 3/4, you might know that you can write that as 0.75, or you can also write them as percentages. So all of those would be absolutely fine to use in the exam. Normally I just prefer to use fractions. Okay, so that's absolutely fine. And we put probabilities on a scale between 0, which is something that is impossible, right? So the probability of me finding a triangle with 4 sides has probability 0 because there are no triangles with 0 probability. The probability of me finding a triangle with 3 sides is 1 because that is absolutely certain. Every single triangle that I find has 3 sides. Okay? But sometimes we have things that are in between impossible and certain. So we use words like unlikely or even chance for that 50-50, probability a half, or when things are much more likely, we put them up here closer to 1 than a half. Okay, so I've got a little challenge for you now. I think that one is here. Here we are. So I've got a probability scale for you, and I would like you to vote in my poll to tell me where on this scale would you put the words even chance. Would you put even chance on A, B, C, D, or E? Over to you. Vote now in my poll. Okay. Don't be shy. Have a go. Don't worry if you get it wrong. Okay, fantastic. We've got 100% success rate so far. Well done. That's brilliant. Don't worry if you make a mistake. That's, you know, what maths is all about, really. You know, we make mistakes, and so long as we learn from them, that is absolutely fine. So please don't be shy here. So where do you think that we might put the word likely on this scale? Let me just clear this poll for you, and then you can share an opinion on where you would put that. So would you choose A, B? I suppose you could argue maybe C, D, or E. Which one are we going for? Yeah, I think everyone's getting it. Absolutely. So that is option D. So, you know, it's more than 50-50. Maybe we've got a number like 0.75 or 3/4 or 75% there for something that's quite likely. Where would we put impossible on the scale? I think you're getting the idea of how these polls work now. Yeah, very good. Absolutely. So impossible goes at letter A with probability 0. So that it's just not going to happen. We know for sure. And what about that word certain? If we're certain something is going to happen, let me clear the poll again so you can vote again. Where would we put that one? Yeah, absolutely. We put that on the letter E, and that leaves unlikely to be somewhere here, right? It's the only option left. Okay, so we've got these words, but we can, you know, ascribe numbers to these. So something that's unlikely might have a probability of, you know, maybe like a quarter or 0.25 or 25%. Okay, so we use numbers to talk about probabilities. Okay, let's have a look at another problem here. Okay, so Normally we use fractions with probabilities. So maybe if I move to this view, can you share in the very leftmost poll what the probability is of rolling an even number on a fair six-sided dice? If you type in your answer, you can use the little slash key on your keyboard to type in a fraction. So if you wanted to type in something like 3/4, you could type it like this. Or you could use decimals if you want to show off, or even percentages here. Yeah, we're getting some fantastic answers through. Yeah, very good. Yes, all of those answers there are absolutely correct. So yeah, we've got on our fair six-sided dice, we've got 6 numbers, haven't we? So we know that our fraction is going to be out of 6. And then how many of them out of 6 are even? Well, those ones I've highlighted, there are 3 of them. 3 out of 6 is equal to a half, or 0.5, or 50%. Well done. Okay, great start here. Let's have a look at another one. Okay, so Mr. Brown puts all the pupils' names in a hat from his school, and he picks one of them out at random. Okay, so he's put all the names in, just picking one out at random. What's the probability that he picks a year 11 student's name? Let me give you some more information so you can answer this. So here's some information about the number of students in the school in each year group. Okay, I'm going to be quiet so that you can have a think about this. Can you share your answer in the second poll? Can you see where it says share your answer to question 2 here? When you've got an answer, share it there. Don't worry if you get this wrong. We'll learn something from it. So if we're not sure about this, we think about probabilities as fractions. So we're thinking, how many pupils have we got in total at the school? Well, in total, we've got 130. And then we're thinking, well, how many year 11s have we got out of that total? Well, the table says we've got 15. So it's 15 out of 130. And if you've got a calculator with you, you can type that into your calculator and it will simplify it for you. So that will tell you it's 3 out of 26 or 0.1153 and so on. So it's about 11.5%, okay, of the time we would pick out a year 11. So very well done. I need to congratulate one of our students who got that. Well done. That's fantastic. Okay, let's have a look at, they're getting a bit trickier, aren't they? Okay, so here we go. So I've got a tub of cubes here. And what I would like you to tell me is what's the probability if I pick one out at random, just picking one out at random, what's the probability, that's what this means, of picking out a yellow cube? So have a think about how many there are in total and how many of those are yellow cubes. I think you spotted where I want you to put it in. Yeah, absolutely. So if we count them up, we've got 1, 2, 3, 4, 5, 6, 7, 8 cubes. Yeah, so we've got 8 in total. Let me make a note of that because we might need that later. 8 total. And out of the 8, we have 5 of them that are yellow. Okay, so how would we write that? 5 out of 8. So well done to all of you that got that. Fantastic. We need to make this a bit harder, don't we? Okay, before we do the harder ones, can you just check that you've got that just in case someone was feeling confused about this one? So just tell me, humour me, what's the probability of picking out a red one if I'm picking at random? So I've put the yellow one back in, by the way. So, I haven't taken one out. It's not so this one is what we'd say with replacement. Yeah, very good. I can see that somebody has put 2 out of 8, and you're absolutely right. We can write 2 out of 8, or we could simplify that fraction. Could somebody either tell me in the chat or the Q&A or in that poll, what's another way of writing 2 out of 8? Absolutely. Well done, Bella. Absolutely. 1 out of 4. Very good. So we can, think of 2 as 2 times 1 and 8 as 2 times 4. And then we can cancel out our 2's here. And then we're left with 1 out of 4, a quarter. Okay, so a quarter of them are red. Here's a slightly trickier one for you. Okay, so what's the probability that I pick out a yellow one or a green one? What are we thinking here? Just share your answer in the poll again or in the chat. I don't mind where you put it. Yeah, this one's a bit trickier, isn't it? So let me add something to our totals here. So we had 5 yellow, 2 red, and you can see we've got 1 green, haven't we? And we're asked for the yellow or green, right? So we had 5 yellow, 1 green. So that's 5 plus 1. That's 6 out of a total of 8. So 6 out of 8. And I'm very impressed that someone has managed to simplify that for me already to 3 out of 4. Because we've got 6 is 2 times 3, 8 is 2 times 4. And cancel out those 2's, leaving us with 3 out of 4. Well done. Okay, slightly trickier question for us. So what's the probability that I don't get a yellow one? Let me just move this out of the way. What's the probability that I don't get a yellow one? Let's clear this. So we're looking at part D. Okay, do you want to put that answer in the next poll for me? In fact, I think you might be getting the idea with this, so I might reveal a few more to you here. You want to see if you can answer all 4 of these last questions for me. So you can put your answers in the chat if you like. If you could just label them for me so I know which one's which. So if you're talking about part D, put the letter D next to it. If you're putting part E, put the letter E next to your answer as well. Otherwise, I'll get very confused. So we're looking at these questions here. Okay, so if we're thinking about the not yellow ones, well, what's not yellow? That's red and green, isn't it? So 2 red, 1 green, so that's 3 out of 8. Oh, look at this. Probability of getting a yellow, that was 5 out of 8. Probability of not getting yellow, that's 3 out of 8. Notice if you add those 2 things together, 5 8s plus 3 8s, getting a yellow or not getting a yellow, you get 8 8s, right? Which simplifies down to 1. And that makes sense, right? Because you either get yellow or you don't get yellow. It's absolutely certain that one of those 2 things is going to happen. You remember we said 1 was that word certain in probability. Okay, so well done. Gosh, Aaron's been hard at work here. Yeah, I mean, this is kind of asking the same thing, right? Because, you know, the probability of getting a yellow or a red or a green, you know, I'm going to get one of those things. So it is also going to be a certainty. Whereas getting a blue one, well, there's no blue ones in there. So that's got to be impossible. So that's 0, remember. And not getting a blue, well, that's absolutely certain. Everything is not blue. So that's the number 1. So well done to all of you. Thank you so much for your contributions there in the chat. Okay, we're going to finish off with a look at one of my favorite problems in maths. And the reason I like this one so much is that it feels wrong. Every time I see this problem, I think, this doesn't feel right. But that's the beauty of maths. Sometimes your gut feeling can be wrong. But if you take a really logical approach, which is what you'll learn in your GCSE maths course, then you can cast your emotions aside and you can, you know, find the correct answer using logic, which is a really great skill to have. So let me describe the Monty Hall problem to you. Okay, so this is a real US 1970s game show. So that's over 50 years, well, around 50 years old now, isn't it? So contestants were told there were prizes behind 3 doors. There were 2 rubbish prizes. So they had goats behind 2 of the doors and 1 really good prize. So they had a car behind the door. So I'm going to ask, would anyone volunteer to have have a go at playing this game show game with me? Would you let me know in the chat or the Q&A if you'd be willing to have a go at this? Have we got any willing volunteers? Okay, thank you so much, Bella. I love your enthusiasm for this. So, Bella, the way that this game works is I'm going to ask you in a moment to pick a door out of the three. Door 1 on the left, door 2 in the middle, door 3 on the right. And then what I'm going to do, because I know there's like 2 goats, right? Whatever you've picked, I'm going to show you another door, not the one that you've picked, but I'm going to show you the other goat. So when you pick, right, you either pick a door that is going to have the grand prize, going to have the car, or it's going to have one of the rubbish prizes. What I'm going to do is I'm going to show you another door that contains the other rubbish prize. And then you're going to have the choice, Bella, to choose whether you stick with the original door that you chose or whether you want to switch to the other open door. So I'm going to show you the doors here. So first question for you, Bella, is which door are you going to pick to begin with? Okay, so Bella's going for door number 2. So Monty Hall, who is the host of the game show, I'm going to play the role of Monty, is going to show you another door, open another door, not door number 2. And I'm going to show you a door where you find a goat. Okay, so behind door number 3, which you haven't picked, you find a goat. Okay, now you've got the choice, Bella. You can either stick with your original choice, you can stay with door number 2, or you can switch to door number 1. What are you going to choose to do, Bella? Okay, so Bella has chosen to stick with it. Okay, I love that, your original choice. So let's, oops, oh, I'm so sorry. We'll do this again. So I misclicked. Bella, I think you're going to choose to stick with door number 2. So let me show you this. So Bella's chosen to stay. And Bella, unfortunately, you've ended up with the goat this time. Maybe we can play again. Bella, let's have another go. So Bella, tell me another door that you want to go for. Give you a second chance. So I mucked up the first one. Okay, so Bella's going for door number 1 this time. So I'm going to show you one of these other 2 doors where I know a goat is, a rubbish prize. So I'm telling you there's a goat behind door number 3. Do you want to stick with door number 1, your original choice, or do you want to switch to door number 2? What's Bella going to do? We're on tenterhooks, Bella. Let us know. Stick or switch? We're going to stick again. Okay, so this time Bella has ended up with the grand prize, which is the car. Fantastic. Now, I guess there's some maths involved here, right? We need to know, like, what is the best strategy here? What should you do in general? Like, if you knew you were going on this game show, you can think about this right beforehand and think, well, what's the best thing to do? Well, you can actually analyze this game mathematically. So let's imagine that Bella initially picks door number 1 on the left. So Bella picks door number 1 on the left. Now, there's some different possibilities that we've got here. So it might be that, as happened in the last game, that the car is behind door number 1 and the goats are behind doors 2 and 3. Now, if Bella's picked door number 1, she's picked the car, well, Monty Hall can either show door number 2 or door number 3 because they both contain goats, right? So can I ask you here, I've got another poll for you, I think. If Bella sticks with her original choice, what would she end up with in that case? So Monty has shown Bella the goats behind door number 2. If Bella was to stick with her original choice, door number 1, what's she going to end up with? Can you vote in my poll here? Is she going to end up with a car or is she going to end up with the goat if she sticks with door number 1? Yeah, absolutely. I think you're getting this. Yeah, door number 1, we know, contains the car, right? So if Bella sticks, absolutely, Bella is going to end up with the car, okay? But if she switches, she'd switch to door number 3, right? And she'd end up with its goat here behind door number 3. So that's one kind of scenario, right? The car lies behind door number 1. But it might be that the car actually lies behind door number 2. So if the car lies behind door number 2 and Bella has picked door number 1 initially, if she sticks with door number 1, well, she's going to end up with the goat, right? Whereas if she switches, well, Monty is going to show the goat behind door number 3, right? So she wouldn't pick door number 3. That would be silly. She'd get the goat. So she's going to pick the car. So if she switches, she gets the car. Okay. So the final scenario, she picks door number 1, which is the goat. Okay, and Monty shows her the other goat behind door number 2. So she's not going to pick door number 2, right? If she sticks with door number 1, she's going to end up with the goat. If she switches, she's going to end up with the car. Okay, so then we're getting close to answering the question now. So have a look at this. These are our 3 scenarios. If you stick, if you stick here, if you switch, can you see 2 times out of 3, you will win the car. Whereas if you stick with your original choice, 2 times out of 3, you get the goat. So can you fill in the sentence for me in that final poll? So tell me the 2 numbers to fill in the gap. So if you will win what fraction of the time if you switch, and what fraction of the time would you win if you don't switch? Can you see if you can fill that in for me? Check you followed this. You can just give me the numbers if you like. You don't have to write out the full sentence. Yeah, so thank you very much for your contributions here. So if you switch, as you can see here, 2 times out of 3, you will end up with the grand prize of the car. But if you don't switch, if you chose to stick, then only 1 time out of 3 would you end up with that grand prize of the car. So it's much better on this game show to switch than to stick. So Bella, you got quite lucky getting that car. I mean, as we see, it can still happen. It's just better if you're playing this game lots and lots of times. It would be better for you to switch on average than it would be for you to stick. But you can see, it's only probability, right? Unusual things can happen in life. So, the maths isn't telling you, that you're guaranteed to win the car here. It's just telling you the best strategy. Okay. So maths can be really useful, but, there is a limit sometimes to what it can tell us. We still have to make the decisions ourselves as humans. Okay, guys, I'm so happy to be able to share that Monty Hall problem with you. Sorry, we've gone a little bit over time. Got super enthusiastic about that one. I'm going to hand back to Rosie to finish off the session.
Thank you, Harry. Brilliant lesson as always, and I always learn something new and test my own math skills in these sort of taster lessons. So thank you for that. As we said, now's a chance to ask any questions that you might have, whether it be specifically about the Maths GCSE course or more generally about Highgrove Online School and the programmes we offer. We've had 1 or 2 questions in, so Harry, there might be some that would be helpful for you to answer potentially. So if we start with those, and then I'll come on to some of the other ones after.
Absolutely.
We had a question about how much time pupils get to spend with their teachers. How often do they see their teachers? Maybe you can just sort of elaborate a little bit on what sort of contact time pupils get.
So it depends on whether you're studying for GCSEs or A levels with us, but either way, for Maths GCSE and Maths A level, you'll have 2 lessons a week with your teacher, and you'll also have the opportunity to meet up with your teacher in office hours. So if you need some extra help with stuff that you've come across in your self-study that you're not sure about, then absolutely you can get that individual support in either open office hours where you can just drop in and ask your teacher questions as you need, or you can book in for individual office hours with your teacher. So plenty of support with us.
Yeah, I'd also add that the class sizes we have are small. For GCSE, it's a maximum of 12 pupils in a class, and for A level, it's a maximum of 10. So it's a good chance then to speak to your teachers and ask questions. And hopefully what you've seen from today is that all of our sessions are interactive. You do get those opportunities to ask questions if you're not sure. And like I said, with the smaller class sizes, it's much easier to do that. We had one question about I'll take this one, coming through a national curriculum rather than the British curriculum to join Highgrove for GCSEs. And can you do that? The answer is yes, you can join us if you've not been following the British curriculum up to now, whether that be joining us for GCSEs or joining us for A levels. We do have an admissions process that involves some admissions assessments, and that can help us make sure you're picking the right course for you. And if there's any concerns about the transition, we can highlight those too, so you can prepare for that change and then join our GCSE or our A-level course. The assessments are nothing to worry about. What I usually get after saying that is a load of questions asking what the assessments are like and what if I fail. They're nothing to worry about. For GCSE, you'd sit 3 assessments, one for English, one for maths, one for sciences. For A-level, you'd sit specific assessments for the subjects you want to study at A-level. But like I said, they're nothing to worry about. They're there to help us assess where you're at in terms of your education and your studies, and to make sure we can help you get onto the course that you want to do at Highgrove. So nothing to worry about in terms of those assessments. I'm just having a look to see if there's any more questions. Like I said, do keep popping them in the Q&A and in the chat if you have any. We've already answered how big classes are, which was one of the other questions. What happens if I don't pass the entrance test? Yeah, always get these questions as soon as I mention them. Like I said, it's not a pass or fail test. It's really there to assess where you're at, and we can put in support if you need a bit of extra help to prepare you to join a GCSE or A-level course. And we have what we call access courses for those. So if you're not quite ready to begin your GCSEs, for example, because you're transitioning from another curriculum, we do have tutoring options and access course options that can help you get there. So please don't let the idea of having to do an assessment put you off applying for Highgrove, and do book and have a chat with me, and we'll talk you through the process. I think that is all the questions.
One more question there, Rosie. Did you spot it in the chat? So is it okay to study maths GCSE with you and not other GCSEs? Because my maths teacher at school is rubbish and I prefer to stay with you. That's very nice of you to say.
Very kind. Yes, it is. So we obviously offer full-time courses for GCSE and A levels where you do all of your studying through Highgrove Online School. But we also offer what we call individual subjects. So you can choose to stay in your local school or college and do possibly the majority of your GCSEs or A levels. But if for whatever reason you want to study 1 or 2 subjects with us because you don't like your teacher or because it's a subject your school doesn't offer, you can do that. It's not a problem. You still join the live lessons. You still have access to all of the self-study material. You get the same support from our teachers in terms of the office hours that Harry mentioned. But you can keep attending your local school, your local college for the rest of your subjects. So that's no problem. We do offer really flexible approaches. So you don't have to join a full-time course. You don't have to study just our core subjects. There's various options for sort of bespoke programs, and we can usually work around what you need and what you want to find what's best for you. Just checking I haven't missed any other questions now before we finish. That just leaves me to firstly thank Harry for his taster lesson this evening. So thank you very much, Harry. I hope everyone enjoyed it. And thank you everyone for joining us this evening. I do also hope that you found it useful to see what a taster lesson's like, to be able to ask any questions you have. Before we just finish up, I'll just draw your attention to the web links box. You can see just under my picture there. There's a few links there to our website and some of our social media accounts. But the second link is also to book a call. So if you go away at the end of this evening and you suddenly think of a question you wish you'd ask, or you want to talk a bit more about what programs are available, what might suit you, do feel free to book a call. You can click on that link now and bookmark the tab, or you can find that through our website. But that's to book a call with me. And like I said, if you've got any other questions, if you're not sure what the right course is for you or how it can work studying alongside another school, just book a call. We'll have a chat and we'll find out what's best for you. Other than that, thank you very much, everyone, for attending this evening. Hopefully, I'll speak to you all very soon. And like I said, do get in touch if there's anything else we can help you with. But have a lovely evening, everyone.
Have a lovely
Bye-bye.
Thanks for joining us. Thanks, Nicola. See you soon, everyone. Have a great evening.